Welcome to Creative World. In this video, we will implement OR gate using ladder logic PLC programming language. Algebraic expression of OR gate is y equal to A or B. A and B are the inputs of OR gate and y is output of OR gate. Here is the truth table of OR gate. We will implement OR gate in ladder logic programming language and justify the outputs according to truth table of OR gate. Before starting the simulation, first I would like to introduce you with the program. These two contacts are normally open contacts and labeled as input 1 and input 2 for two inputs of OR gate. This one is output contact labeled as output of OR gate. Now we will run the simulation and justify the inputs and outputs of OR gate in truth table one by one. In this simulation, we have two contacts I3 and I4 that are labeled as input 1 and input 2. And two outputs are there, one is Q3 and other one is Q4. This bottom branch is used for NOR gate. Right now we will skip it and we will focus only I3, I4 and Q3. So our focused contacts are I3, I4 and Q3. We will start from here and justify all the outputs one by one. Run the simulation. In first case, both inputs are 0. It means both inputs are low. It is not blinking. Right now skip Q4. Just focus on Q3. So first entry is verified. In second entry, input 1 is 0 and input 2 is 1. Input 2 is 1. Make it 1. In this case, the output should be high. The lamp Q3 should glow. Here you may see lamp Q3 is glowing. Here I would like to share a point. 0 mean contact is in normal state, contact is open. 1 mean contact is in detected form, closed form. So we will move towards third entry. Input 1 is 1. It means input 1 is closed and input 2 is 0. In this case also the output should be high. So the output is high. Q3 is glowing. Move towards the last entry. Both inputs are 1. In this case the output should be high. Now both inputs are high. The output is high and it is verifying the truth table. So we have successfully implemented OR gate in ladder logic programming language. Now we will move towards NOR gate. We know that if we add an inverter on the output of OR gate, we will get NOR gate. Algebraic expression for NOR gate is y equal to A or B complement. Y is the output of NOR gate and it is the complement of A or B. We can see this difference in truth tables. The output of NOR gate is basically the inversion of OR gate output. By taking the OR gate output complement, we will get the output of NOR gate. In order to take the output complement of OR gate, we have used a normally closed contact. This normally closed contact is working as an inverter in front of OR gate. So its output will be equal to the output of NOR gate. In order to justify the output of NOR gate, we will focus only on Q4. I3 and I4 are inputs of NOR gate and Q4 is the output of NOR gate. We will start from here when both inputs are 0. 0 mean both contacts are in open state. In this case, the output of NOR gate should be high. You may see Q4 is high when both contacts are open state or 0 state. Now move to the next entry. Input 1 is 0 and input 2 is high. Input 2 should be high. In this case, the output of NOR gate should be 0 and you may see Q4 is off. Go to the next entry. Input 1 is high and input 2 is 0. Input 2 is 0 and input 1 is high. In this case again the output should be low. You may see the output is low. Q4 is 0. Move towards the last entry when both inputs are high. I3 and I4 both are high. In that case, the output should be 0, and you may see the output Q4 is 0. So this was the implementation of OR gate and NOR gate in ladder logic programming language. In coming video, I will implement AND gate and NAND gate in ladder logic programming language. Thank you.